Alright everyone, so let's get along with the next question in series. Now the question number 11, what does it says? A metal piece of 160 gram lies in an equilibrium inside a glass of water. There's a metal piece, the mass has been given as 160 gram. It is lying equilibrium, that means the net force will be 0. The piece touches at the bottom of the glass with a small number of the points. So the entire surface is not in contact, just the few small points that are in contact. If the density of the metal is 8000 kg per meter cube, find the normal force exerted by the bottom of the glass on the metal piece. Okay, so as we know that the weight mg will be acting downward and upward acting force will be normal plus the buoyant force. Because the entire surface is not in contact, there are a few points that are in contact. Apart from that, the water will be there. So if I just write the equation, it is going to be mg equals normal plus fb, that is the buoyant force, and we are supposed to find out the normal reaction. So we can write the normal would be nothing but mg minus fb. So we got mg minus fb would be volume inside into density of water into g. Now mg minus volume, we are not aware about the volume, but certainly we know density is nothing but mass upon volume. So volume would be mass upon density. So we can write mass upon density of the object into density of water into g. If I can just take out the m as common, so mg would be common, it becomes 1 minus density of the water upon density of the object. So mass was 160 times 10 raised to the power minus 3 times 10. Because the mass was given in gram, and to convert gram into kg, we multiplied by 10 to the power minus 1 minus 3. 1 minus density of water, we already know, and the density of the object was given as 8000, that is 8 times 10 raised to the power 3. So does it cancel out? So we got 7 by 8, that is 116 times 10 to the power minus 1. These two zeros get cancelled out and it becomes 7 times 8, so that will be 2. So we are getting 2 into 7 into 10 raised to the power minus 1, that is 14 times 10 to the power minus 1, and the normal force would be nothing but 1.4 Newton. That is the answer of the question. It is as simple as that. Just Archimedes principle will be applicable here. The normal reaction plus buoyant force should be equal to mg. Okay, let us go with the next question then. What next question says? A ferry boat has an internal volume of 1 meter cube and weighs 50 kg. The volume has been given to us, which is 1 meter cube, and the weight is given as 50 kg. Neglecting the thickness of the wood, find the fraction of the volume immersed in the water. Now look carefully what they have asked you to find out. Find the fraction of the volume of the boat immersed in the water. We don't need to find out the total volume immersed in the water, but we're supposed to find out the fraction of it. So if I just draw the boat diagram right now, for example, this is the boat that we have, and it was kept inside the water. So obviously up to this point the water will be filled, not complete fill will be there. So, and as we know that the downward force acting would be nothing but mg, and the upward force acting would be nothing but v into rho into g. And obviously for part A, if I write in equilibrium, if everything is in equilibrium, so the downward acting force is mg and the upward acting force would be v rho times g. Of gg get cancelled out, so we got m is equals to v into density. Now what is the mass of that object? It is 50 is equals to, the weight is given as 50 kg already, and the value of volume inside, that means volume that is submerged into density of the water was, we already know, that is 1000. So volume submerged is coming as 50 times 10 raised to the power minus 3. So that's going to be 5 into 10 to the power minus 2 meter cube, that is the volume submerged. But we are supposed to find out the fractional volume, that means we're supposed to find out v submerged upon the original volume, that is 5 into 10 to the power minus 2 by 1, so that is 5 by 100, and in centimeter is going to be 1 by 20 centimeter. That is the answer of option number A. Now if they ask us, if leaks develop in the bottom and the water starts coming in, now imagine that the boat is like this and the leak has started to come in, so the water will flow in this way, right? So the moment waters start to pour into it, the boat will go down, down and down, and at one point of time the complete boat will be submerged into the water, and then water will start coming from this side as well. That is part B they are asking. Or they said, if a leak develops in the bottom and the water starts coming in, what fraction of the boat's volume will be filled with the water before the water coming in from the sides? So before, जब पानी उसके अंदर आएगा साइड से, तो साइड से पानी आने के पहले बोट के अंदर जो लिक्विड भरा होगा, whatever the mass of liquid will be filled inside the water, we are supposed to find that out. And it will be again as simple that the mass of the boat mg is been acting downward, the mass of water into g will act downward, and the buoyant force will be acting in the upward direction. So we can write that the net force should be 0. So it is mass of water plus mass of boat times g should be equal to the buoyant force. Okay, so if you just write the equation of the buoyant force, we get mass of water plus mass of boat times dg is equals to v into rho into g. Now this v would be complete because the boat was being submerged into the water. So the total volume was submerged and the total volume of the boat was given as 1 meter cube. So we might put that there. So mass of water plus mass of boat times g should be equal to 1 meter cube into density of water. We know that is 10 raised to the power 3 into g. And if we can cancel out g and g, they will cancel out. Mass is going to be 50 times the mass of boat. It is 10 raised to the power 3. Okay. It is 10 raised to the power 3 that we have got. Now if you just put what we're supposed to find out? We're supposed to find out what was the boat's volume. What was the boat volume will be filled with water. So volume of water we need to find out. So what we can do is we can just write 50 plus density of the water, right, into mass of water. Okay, 1 minute, I think I have made a mistake here. It should be mass of the water. Okay, so not density, it should be volume of the water is equals to 10 raised to the power 3. Okay, now if you just write 10 to the power 3 into volume of the water, it is 1000 minus 50, that's going to be 950 divided by 1000. That is the volume of water, and this 0 get cancelled out. It is coming as 19 by 20. That is the volume of water per meter cube filled inside before the water starts to pour in from the side, because they want us to find out the volume. Understood? So in this first question we need to find out the volume submerged when there was no leak, and when there was a leak the water fountain will start to go up, and we will find out the what is the volume of the water submerged inside the boat. Okay, so now let's go for the question number 13. What does it say? A cubical block of ice floating in a water has to support a metal piece. Let us draw the diagram first of all so that it can be visualized properly. The water was filled up to this level, and what does it say? There is a block of ice which has been there floating in the water, and it is supporting a metal object of the mass 0.5 kg. It is of 0.5 kg metal. The ice is supporting that. What can be the minimum edge of the block so that it does not sink? Block means what is the minimum value. For example, if this is x, this is also x. So we need to find the value of x so that it will not sink. As we all know that it is the law of flotation कि जितना भी force नीचे act करेगा, if the upward acting force will be equal, it will not go down. So downward acting force is nothing but mg, upward acting force is nothing but the buoyant force. So we can write mg should be equal to the buoyant force, but mass would be of mass of ice plus mass of the cube that has been kept over into g should be equal to volume of the ice that is inside the water into g. So again g get cancelled out. Volume of the ice, what we can write? Mass of ice we don't know, that they have given the specific gravity of the ice is 0.9. So we can write it as 0.9 times x cube plus relative density has been given plus mass of the cube is given as 0.5 kg should be equal to 1000 times of x cube. Total volume, if it is a cubical volume, so volume is going to be x cube. So 1000 times x cube, and then if we just simplify it further, 0.9 x cube plus, we will convert that into gram, because I have taken the density of water to be as 1 gram per centimeter cube, so I don't have to multiply that. I will just keep it as 0.9, and this is going to be again 1, convert back into the 1. This is 1 gram per centimeter cube. It will be easy for us to understand. 1 x cube, so we got 500 gram is equals to 1 x cube minus 0.9 x cube, and after simplifying that we get 0.1 x cube should be equal to 500 gram. So if I calculate the value of x cube, it is going to be 5000 gram, no, not gram, it is going to be centimeter cube, gram per centimeter cube, so it is going to be centimeter cube, and that is going to be centimeter cube. Now if I take the cube root of x, it is going to be root 5, cube root of 5 times 10 centimeter, and it is approximately 1.7 times 10. So I guess the answer is supposed to be 17 centimeter. So this is the length over which that is should be kept inside the ice, so that it will not be allowing the cube to get sinked. Okay, so in each and every question what we are doing is we are just trying to find out the buoyant force, the condition of buoyancy, and then simplifying it further to get the proper answers.